All right, so tonight I am working on my last session on a project that I've been on for a few weeks, and I have over 100 hours of data captured in RGB with just a luminance filter. And I have been working on a trilogy of galaxies in the M81 group. M81, which is Bode's galaxy, about 12 million light years away, and M82, which is the Cigar galaxy, also about 12 million light years away. The Cigar galaxy is an interesting target. It has kind of like a starburst, red filaments that are coming out from it. And my goal tonight is to capture some of that red data in dual narrowband, which is, those are like hydrogen filaments. And then also is NGC 3077, which is a little over 12 million light years away. I believe it's a little bit smaller galaxy, and it definitely appears that way in my image. And then it has a really wonderful star field around it too. And I'm hoping that all of the RGB data I've got will really add to the star color and so forth in my final image. So after tonight, I want to take a look at the effects of a number of stacked images on the signal to noise ratio. I want to do an estimate based on the first image to find out how many images I would need in order to get a signal to noise ratio of 100. And then I have that data. I'm going to apply that and more if needed, and am going to find out exactly how many images I actually needed in order to get to 100. So it should be an interesting experiment, and hopefully learn a little bit about signal to noise ratio, and I wanted to share that experiment with you. So anyway, let's get going on it. All right, it's just an absolutely clear and beautiful night tonight, and I hope that this session goes really well and I can wrap up this project. I'm excited to see what things turn out here tomorrow morning and get into this SNR project. Everything started up pretty good. My focus run was a little sketchy. This is the first time I've had my dual narrowband in there for, almost a month now. So that's probably contributing factor. It's just I was pushing it as far as my start time. It was still a little bit twilight. That might have contributed to that. But first image came in, looked pretty good. It's only going to get darker, so we'll see how things go. Anyway, I'll catch up with you in the morning, and we'll jump into this SNR experiment. I'll talk to you then. Hey, good morning. I had a beautiful night last night. Got about 108 subframes with the duo narrowband. It looks like it was just a really good night. I haven't had a chance to review and go through and blink images yet. I'm going to go in and get that done and get all of my stuff together and ready for some data entry to take a look at the RMS and the effect of subframes added on RMS and see if the estimates and actuals are pretty close, and hopefully I'll get an idea of how many subframes do I really need to get to 100 RMS. Got all my calibration frames done and getting ready to shut this down for the day. So anyway, gonna go ahead and get some breakfast, and then I'm going to join back with you here in just a little bit. All right, so it's actually been like a couple weeks since that last clip, and I decided to go ahead and put the same shirt on so that I had some continuity between clips, but hey, I didn't want to try to pull the wool over your eyes on that. So anyway, it's been a while, and hey, I apologize that it has been a while. Sometimes it's really hard to be motivated to spend the time and energy into creating the video content. It really consumes a lot of time, and honestly, I've had almost an entire day today trying to put all this together. So I hope you understand, and I try to remain consistent, but I just felt like I needed a little bit of a break there. But thanks for bearing with me on that. So in this video, I'm working on getting together kind of an analysis of the data that I've had on a project. I've got over 100 hours of subframes captured on basically the Bode's galaxy, in a trio of galaxies that are there in that group. I did that in an effort to see how much data I actually needed to get and see if I could get to 100 for the signal to noise ratio. So anyway, I want to look at that with a couple different tools, and we'll look at that in a spreadsheet by Craig Stark, a very smart guy who had put together a bunch of calculations back in 2009 with various others, and it was posted in an article on cloudy nights, and I'll leave a link to that article down below. The spreadsheet itself isn't really available anymore. You'll have to hunt around for it. The link that is in the article is a dead link now because this was from 2009. But with a little bit of searching, I found an actual copy of the spreadsheet and downloaded it, and then I've been using that. But I don't think I have the rights to make that available. But if I can help you find it, certainly post down in the comments, and I'll see if I can point you in the right direction on that. The other tool is by Mark over at Deep Sky Detail, and he wrote a tool for signal to noise ratio that's based off of that spreadsheet. And I'm kind of using both of them, and the numbers actually are working out really close. I'm pretty sure that he took the calculations off the spreadsheet for using in his application, and I think it shows that getting the same results on that. So anyway, you wouldn't necessarily need the spreadsheet. The reason I wanted to get the spreadsheet is because I could have a look at the underlying calculations that are in the cells that are doing the analysis and providing the results, and I was hoping to get a little bit better understanding of how the algorithm actually worked. But anyway, we can kind of jump into looking at the data now, and we'll see what we end up with. All right, so starting over here in my file tree, I have my project, which is the Bode's Galaxy project, and this is a group of galaxies that is imaging. And if we look at a single light, I've got Bode's, the Cigar Galaxy, and there's one other small galaxy up here. And I wanted to look at how many images it would take to get to the signal to noise ratio. Now, I didn't look at this ahead of time. I just decided I was going to go for getting over 100 hours of data captured. And if we look at the spreadsheet here in this area, on these dates, I have my sessions and the number of exposures that I had for each of those sessions, which gave me a total image count of 2,070 180-second images. And if I do the math on that, that was 103.5 hours of total integration time. So what we want to do is we need to fill in some blanks here on this spreadsheet. So we've got these top 5 which we need to get the data from, and so the sky glow background, which is going to be the measurement of the ADU of the background of an image, the target signal, which is going to be a measurement of a section of the actual DSO and getting the signal off of that, so the ADU. Then we'll grab the dark from that session and get a dark signal from it, and a bias from that session and get the ADU from that bias. I've already got exposure filled in here at 180. And then gain and read noise. So if I look at that for my camera, which is an ASI 533 MC Pro, we can get the gain value here. So, and I'm running at a gain of 100, which has an ADU of 1.0. So I would enter 1.0 into the spreadsheet here. And then my read noise I can get from the same resource. If I come down to my read noise, and at 100 gain, my read noise is 1.5. So I've entered 1.5 here. So the first thing I want to do is just illustrate how grabbing one single subframe out of a session doesn't really work, and we can take a look at the numbers and kind of illustrate why that doesn't really work. So if we open up, in this case I'm using Siril, you're going to need some type of processing application that will allow you to get the ADU value from an image. So if we open up, and I've got the light that's opened right now already, and then in Siril we want to get statistics. So the first thing I'm going to get here is the background glow, and so I'll select some background here that's near my target, and I'm going to hit statistics. On this, I mean, there's probably a few different ways to do this. I don't know that it matters. You could take one of each and then just make sure that you do the same one. So if you choose a red channel, then just keep using the red channel. Or you could, if you wanted to get maybe more accurate, you could take the average of the 3 channels. I'm not going to do that. I'm just going to take the red channel for now, so which is 3196.7. And so I'm taking the mean value of the red channel, 3196.7, and I'll take that over here and I'll plug that into the sky glow. So 3196.7. All right, and then we need the target signal. So for the target signal, I'm going to come over here on the target, and it's a little bit, maybe if I come out into histogram, you can see it a little better. And it doesn't matter, the statistics are based on the source image and not how you're viewing it here. So you could choose histogram so you could view it. And let's say I want to get target of this area of my DSO, which captures a little bit of both the bright and the dark, and then the fainter area here. That should give me kind of a decent average of that. And go to statistics, and the mean on that is 3284.1. So we'll enter that here in the target signal, 3284.1. Okay, then we need to get our dark. So if I go over here and back out and go to my darks and open up my master dark on that. And I'll make a selection and do statistics. Then my mean value on red is a 396.6. 396.6. All right, and we need the bias signal too. And so I'll go over and open, go to my biases. We'll grab a bias and open it and get statistics on that. And that's 395.7. Okay, and that's all we need because I've already filled out my gain and my read noise. The only other thing is that I want my, to make sure and fill out my target signal to noise ratio, which I've put here is 100. And then I also had my exposure duration here already set at 180. So what we can then look at if we go over to the stacking tab is that with the number of images that I currently did, you know, my signal noise ratio is like 1.6. So if I go to sub-exposure length here, then it's saying that I could get a signal with 900 images based off of this one. I could get a signal noise ratio of like 12, which is basically this point right here. So this is why doing this off of a single sub isn't very useful, because we're just not getting numbers that give us an indication of what we really need. And so, you know, we could say, you know, well, how many images would I need here? You know, so if I copy that and let's say I put in 1,000, you know, that's giving me 51. What if I get 2,000? That's giving me 72. So I could say that, well, I need 2,000 images to get to 72. But so anyway, this is, the more data that you give this, then the better your estimates are going to be. So at this point in time, using a single subframe, we're getting an estimate of around 2,000 images to get to 72%. I believe we'll see a better result as we start doing stacking than what we're seeing with the single image. If I go back to the param calc worksheet here, you know, I've got a total of 2,070 images, so I'm definitely expecting to get better results than 72% with that, but we'll see how far we go. So with that, I have already done one stack, so I'm going to actually, I'm going to repoint my home here. All right, so this is my my bode stack. I did this before I started recording here, just so you wouldn't have to watch it, but I will speed through the next one. So if we go into my RGB directory here, and this is my my session, so I've got all of my masters here from that session. So I'm going to open that as my home, and then we want to look at this one here. So this is the RGB stack. So I'm going to open that, and we'll go maybe to something that we can kind of get an idea. Okay, so from here I can kind of do in the same area and get a statistic off of that. So ADU now is 2539.3. So let's go back in and switch up some numbers. So 2539.3. And then we'll get the same area down here. And that's 2597.5. Okay, and then we need to get to our dark. So let's load that up. And I'll load the master dark. We'll get a statistic on that. So we're at 396.5. pretty close to the other one. And then the bias. So we're at 395. Again, close. All right, and all else stays the same. So now if we go back over to our stacking tab, so at 2000, it's telling me that we're going to have a target signal to noise ratio of 56. So to get to 100 with our current stack, yeah, so around 5,000 subframes. So what I'd like to see is how these numbers change then as we add more to the stack. So I'm going to go into Siril and I'm going to add a session and stack it. All right, so that stack completed. So let's take a look at what impact having 2 night sessions has on our overall numbers. And all else stays the same. So if we go to stacking, so 1,000 images at 43 now, 2,000 at 60. I think we went up just a little bit there. All right, let's stack one more, because right now we're looking at, we've stacked 150, 171, so 321 images. So let's go down and we'll add in, like I'll just go by date and we'll just add in through the 28th, and then we'll do one more after that. So, all right, stacking completed. So let's go through this process again and see what impact more images are having. All right, so we made a pretty decent jump there. At 2,000, we're up to 88 target signal to noise ratio with the current stack, and we're well over 100 at 140. So to get to 100 at this point, let's say 3,000, a little less, 2,500. Yeah, right in that neighborhood. So anyway, as you see, as we add more to the stack, we are climbing and to a little bit closer to where we are with the target signal to noise ratio. So getting the estimate, it's kind of ambiguous, if you will, until you continue to add more, because we're getting updated target numbers every time that we do a new stack. Again, you know, with just a little bit of understanding that it's just giving you an estimate, that you can get an idea early on about what you're going to need, you know, as far as trying to reach a particular. But anyway, I'm going to go ahead and finish off, and we'll take a look at what the impact of the full 2,070 images has. So I'll go ahead and set up that stack, and we'll enter those in. And I won't keep you on this one. I will be back in just a little bit. All right, that was about a 35-minute stack. And yeah, obviously it's a big project. I think we had 16 sessions in that. So here's the result file from that, and we'll go ahead and look at getting our data into the spreadsheet and see where we're at. So let's see what effect that had. All right, so that really jumped us up. So based on that calculation, I'm sitting at about 100, a ratio of about 145. So we're well over. We can kind of see the effect of that. So I wonder if we took, yeah, so 2070. So 148 is what my final ends up being. So what I'd like to do now is take this over to, yeah, I wanted to, I'll leave this link here down in the description. This is the article that I was talking about. This is part 2 of the article, which actually gets into discussion of signal to noise and the calculations. The part 1 was kind of an introduction to that. Part 1, it's linked at the top. This goes into a deep dive on the actual calculations. So this is the tool that Mark created over at Deep Sky Detail, and he basically took the original calculations from the signal and noise calculator by Craig Stark and made a nice application around that just basically allows us to plug in and then gives us a graph of our signal and noise over exposure time, and then also how many exposures you're going to need. Here, let's take a look at this. So if I go back to my calculations on my final one, so I had a sky glow background of 1854, which is actually the second. And then if I go to the target signal and grab that value, and we'll put that in the first one, that's the target. And then my dark signal value, and then the bias signal. And then we can enter in camera gain for me, which was ADU is 1, and the read noise for my camera is 1.5. I'm looking for desired signal and noise ratio of 100, and let's say I'll have up to a little over 2,000 exposures, and my exposure duration is 180 seconds, and we won't multiply that. So this says I'll need 945 exposures to get a signal and noise ratio of 100 at 180 seconds. So let's go just double check. We'll plug that number in and see what this actually says. So at, what did that say, 985? Yeah, and so that gives us like 102. And this is cool because you can kind of plot on the graph to see. So let's say you wanted to go for a 75, or you just want to kind of get an idea of, I'm willing to take 500 subs. Where can I go with that? I've got time to do that or something. Where can I get, in one night? Maybe I can get 180 subs in one night, so I might get to a signal noise ratio of 43. So anyway, really handy tool. I'll leave a link to that down in the description as well. So anyway, I hope you enjoyed this video. I just wanted to go through this as an exercise to better understand signal noise ratio and get an idea of just expectations on in my sky conditions, in my border area, as to how many exposures do I want to get, and to get to a certain place, in signal and noise. And I think that generally with where I'm at with my gear and skies, I'm never anywhere near 100 by any means, but I think that I get pretty close to 60 or 70, and I've been pretty happy with that. So I think visually, if you can get to that ratio, I think that you'll generally be happy with your images. So for the particular image here that I just got done stacking, I'm going to be processing that over the next couple days. And then I'm going to post that up on my Buy Me a Coffee. I'll have a link down below for that. If you like this video, if you like my content and like to support my channel, you can certainly do that over at my Buy Me a Coffee, AstroAF. So I'm going to post it there for a pre-release because that's one of the perks of the memberships over there. And then I'm going to, a few days later, I'll go ahead and make that available publicly. So make sure and subscribe and click the notification bell so you'll find out when that image will be posted. That'll be in my community page. So anyway, thank you very much, and I really appreciate you and your support. And if you have any questions or anything, be sure to chime in the comments, and I will talk to you later.